All right, so we're in part 3. Let's just jump straight in. So we'll start with question 21. So find the probability of randomly selecting a boy or a non-soccer player from 12 boys, 7 who play soccer, 15 girls, 10 of whom play soccer. Okay, so what we want to do is we want to ask a few questions. Is this problem an and problem? Either or is it kind of like at least one? And in this case, we're looking at either or. So then you have to say, is there overlapping or no overlapping? Well, let's see. We have a boy and non-soccer players. And since non-soccer players can be boys, we have overlapping. So there is overlapping. So in that case, we're looking for probability of A or B, which happens to be the probability of A plus the probability of B. In this case, the probability of A is a boy. Probability of B is non-soccer. And then we want to then subtract the probability of A and B. So where both are true. Probability of A, what's the probability that I have a boy? Well, there's 12 boys out of 27 people. 12 boys and 15 girls. Now we want to add to that the probability of B, that they're a non-soccer player. Well, if there's 7 who play soccer and 10 who play soccer, that's 17. So there are 10 non-soccer players. So I add on 10 out of 27 because there are 10 non-soccer players. Now, what's the probability that you're not a soccer player and you are a boy? Well, there are 5 boys who don't play soccer. So I'm going to subtract those 5 boys who don't play soccer, or 5 27ths. So I get 22 minus 5, which happens to be 17 over 27. And since it's in decimal form, I just have to divide this. And 0.63 is my answer. There we go. We circle that and we move on to the next question, 22. So the contestants in a competition are 36 women and 22 men. 5 women winners are chosen randomly. What's the probability that they're all women? So first ask, is this and, either or at least? In this case, let's see, contestants in competition, 36 women, 22 men, 5 winners, the probability that they're all women. So and, the first one's a woman, and the second one's a woman, and the third one, okay? So now the question is it dependent or independent? Well, if I select the first woman, then it drops down. So it is dependent, okay? So if you remember, that means the probability of A and B, which is equal to, and because we know it's and it's dependent, we know that's the probability of A, the first one's a woman, times the probability of B given A, and we just keep multiplying that down. So let's go through this. The first one is we first select a woman. Congratulations, yay. Well, there are 36 women, but there are 58 possible ones. Now we drew the first woman winner, so now we go to the second option. But remember, given A, we now subtract. So we're going to multiply this by 35. Women are still in there, but we only have 57 now. And we're going to get 5 winners. So there's the second winner. There's our third winner. Remember, we're subtracting because we drew a woman on each one of these. We want to know all women, so we just keep going down with this. So 33 out of 55. We have 4 winners now. And here we go. Here is our 5th winner. So now with those, we can just kind of go ahead and multiply across. 36 times 35 times 34 times 33 times 32. And now we'll divide that by 58. Divide that by 57, divide that by 56, divide that by 55, divide that by 54. So 8.2% roughly, which happens to be A. So we circle that and move on to the next question. 43 people who answered yes to question 9 were male. Of the 41 people who answered no to question 7, to the question, 7 were male. Okay. If one person is selected at random from the group, what's the probability that the person answered yes or was male? So notice we are looking for an either or. So that right there, the either or, lets us know that. So we're looking for either or. Now we're looking for overlapping. We're looking for, could there be overlapping? Yes, there could be, because we have a male and he could answer yes. So there is overlapping. So because we have either or and overlapping is taking place, we're going to need to remember that we're looking for the probability of answered yes or was male. So A will represent yes and B will be male. So I'm just going to think about those as I work through this. Now, as I look at that problem, remember that's the probability of answering yes plus the probability of being male minus the probability that you are answering yes and you are male. So in this case, the probability of A, we're looking at this, let's see, there are 43 people who answered yes, okay? So 43 people answered yes out of, let's see, total 43 plus 41 is 84, so I can put 84 there. So 43 out of 84. Now I want to add on to there who are male. Well, we know that 9 were male on the first one, 7 were male on the second one, so that's a total of 16. So we have 16 male out of 84 people. And now we want to subtract those who were male and answered yes. Well, that was 9. So that was 9 out of 84. And there's our calculation. So let's go ahead and figure this out. 43 plus 16 minus 9 is 50 over 84, which happens to be 0.59, or roughly 595, because there's 3 decimal spots. And so we can select B and move on to our next problem. 24. In a town, 39% of adults exercise 3 times per week or more. Find the probability that 5 adults selected at random from the town all exercise 3 times per week or more. Okay, so first off, is this probability an and? Okay, probability of 5 selected at random from the town all exercise 3 times. So this is an and, even though the week or more could throw you off. So you have to make sure you read it carefully. So we're looking for an and. So the next question you have to ask yourself, is this dependent or independent? Well, if I selected adult, each event is, 39% of the adults exercise 3 times or more a week. So this is independent. So it doesn't matter upon me selecting. So we're going to say independent. And so if you remember, that is just going to be us multiplying across the probability of A and B such that probability of A, probability of B, so on, so on. Okay? So that's how this is going to kind of look. So I'm just going to say we have 5 adults, so I have 0.39, okay, times 0.39. There's my second adult. And since it's independent, I can use the same probability for each of those. Now I have 5 adults, so I go 0.39 times 5. You can also do that by raising to the 5th power. Okay, so 0.009 would be my answer. A is the correct answer on this one. Question 25. In how many board games are you allowed to another turn if you roll doubles, 2 of the same number? What is the probability that you could roll, this could happen to you 2 times in a row? Okay, so we're looking for 2 things, and so I rolled doubles twice in a row. So if this is an and, okay, and because each roll is independent of each other, this is independent, then I'm going to follow the same rule. Okay, the probability of the first event times the probability of the second event, and so on. If I have the probability of the third event, so on. Okay, so now what we're going to do is, what's the probability that I roll doubles, 2 of the same number? Let's think about how many options there are. Snake eyes, 1 and 1 would be 1 option, 2 and 2, 3 and 3, 4 and 4. There are 6 options. Now how many options do I have with dice? Well, I have 6 options on the first dice, 6 options on the second dice, so that's 6 times 6, or 36 total different combinations I can have by rolling the dice. So rolling doubles on the first one is 6 over 36. Rolling doubles again on the second term, because it's independent, will be the same exact thing, 6 over 36. And if I do that, notice 6 goes into 36 6 times, and 6 goes in, so I'm left with 1 over 36. And I can calculate that by going 1 divided by 36, or 0.0277, which rounds up to 0.028. On question 26, find the probability of getting the sum of either 4 or 7 on a roll of 2 dice. Okay? Now notice that, is this and, or at least? And the answer is it's either or. So I know it's either or because I said 4 or 7. Now overlapping is the next question. Is there overlapping? Well, 4 and 7, there's no overlapping, okay? Because you can't have a 4 and a 7. None of the overlapping. Which means I don't have to subtract this. So I'm looking for the probability of rolling a 4 or a 7. So remember, that's the A and B just refer to events. So in this case, it's just going to be the probability of A minus the probability of B. That's how I'm thinking about this. I'm sorry, adding them together. And I don't have to subtract because there is no overlapping. Okay, so I just add those up. Now let's see, the sum of 4, how many options do I have? Well, I could do a 1 plus a 3, or a 3 plus a 1, or a 2 plus a 2 are my options. Okay? Now, because the 2 plus 2, if you think about that one, I don't write it again because if you switch those, you still roll the 2 on each one, so that actually happens to be the same event. So I have 3 options. So 3 out of 36 are rolling a 4. Now I have to think about all my 7s. 1 plus 6, and 6 plus 1, 2 plus 5, and 5 plus 2, 3 plus 4, and 4 plus 3 are my options. So I have 6 options here. So 6 over 36. And I'm going to add those two together to get 9 over 36, which when I reduce that becomes 1/4, or 0.25, and so C is the correct answer. Let's move on to 27. A study conducted at a certain college showed that 60% of the school's graduates find a job in the chosen field within a year after graduation. Find the probability that among 7 randomly selected graduates, at least 1 finds a job in his field. So this is not and or either or, but is at least 1. So this is, we're going to use that formula. So at least 1 lets me know I'm going to have to figure out, so how many trials do I have? Let's see, there are 7 randomly selected graduates. So I have 7 trials. So 7 trials. Now remember, we're looking for the probability that at least once among those 7 trials, I get the event, which in this case is that we get one that was in a chosen field. Okay? So probability that at least one works in the field. In 7 trials. Okay, and so if you remember the formula, and you might need to use a sheet for this, it's 1 minus the probability that not even, so we didn't get anyone, okay? So no one raised to the power of n, okay? It's the probability right there, okay? So that's what we're looking for. And in this case, what we have is 1 minus, now what's the probability that I don't get anyone? Now 60% of the graduates find a chosen field, so not getting anyone is 0.4, and we'll raise that to 7 number of trials. So 0.4 raised to 7 will give us that value, and then we're going to 1 minus that, or I can subtract 1 and then take the negative on this. So it's 0.9983. So D is the correct answer. All right, 28. An insurance policy sells for $730. Based on the past data, an average of 1 in 60 policyholders will file a $10,000 claim. An average of 1 in 220 policyholders will file $20,000 claim. And an average of 1 out of 300 policyholders will file $50,000. What is the expected value of the company per policy hold? Okay, so we're going to look for the expected value. Let's see. They sell for $730. So sell for $730. 1 out of 60, so there's the odds. Will file $10,000. Okay. 1 out of 120 will file a claim for $20,000. And 1 out of 300 will file a claim for $50,000. Okay. So let's find the expected value of each of those events. So we first have 1 divided by 60, multiply that by 10,000. So about $166.67. And then we'll do the same thing, 1 divided by 120, multiply that by 20,000. And we were going to lose roughly about 166 for all of those policy filling out. And we'll do the last one, 1 divided by 300, multiply that by 50,000, and we lose about 166. So each of those we're losing about that much. So I'm just going to multiply this one by 3. So we're losing about $500. So if I add those up together, we lose about $500, okay, on each of those. Now remember, the expected value is how much we make, so we have to take the 730 minus the 500. So 730 minus 500 would give us our expected value that we make off of our insurance policies are $230, or B. All right, 29. Suppose a charitable organization decides to raise money by raffling a trip worth $500. Now 3,000 tickets are sold at $1 each. Find the expected value of the person who buys the ticket. Okay? So the first thing we need to do is consider one ticket. Well, if you bought the ticket, you have a 100% probability of losing $1. So I'll add that over there. Now what's the probability that you win? There's 3,000 tickets sold. Well, you have a 1 in 3,000 chance of winning that $500. So we'll do $500 divided by that 3,000 gives us that odds, or 16 cents roughly. Okay, 17 cents if you round that. So 17 cents we lose. So if we add those up, okay, so I'm going to subtract a 1. The expected value is losing 83 cents. Okay, so losing 83 cents is my expected value. Question 30. The insurance company sells an insurance policy for $1,000. There's no claim on the policy. The company makes a profit of $1,000. If there is a claim, the company faces a large loss. Therefore, the expected value to the company per policy is $250. Which of the following statements is or are true? Let's look at these. Okay, letter A. The most likely outcome of any single policy is a profit of $250. And the answer on that's incorrect. That's not true, because you're going to lose some, okay? So you can't just choose a random policy and say, we're going to get $250 profit off this. Some of those you're going to get $1,000 because they're not going to make any claims. Where you're going to lose money is when they start making claims. So in this case, A is not likely, so we can actually scratch that out. So we can also scratch out A down here because it contains it. If the company sells only a few policies, its profit is hard to predict. And that's true, okay? The lower number of policies you sell, the reason that they want big numbers is because then it evens out, and then remember, this goes back to that law of large numbers. If the company sells a large number of policies, the average profit per policy would be close to 250. And that, once again, is true because remember the law of large numbers says, as you do this more frequently. So both B and C are true, and so D is the correct answer. And that finishes part 3.